This is Algebra 1, Semester 2, and it's a unit on quadratics, unit number 3, and this lesson is called Factoring Trinomials Practice. It's actually lesson number 13. It's on creatormath.com under the Algebra 1 tab, and the instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for these pages from creatormath.com. So just to model that quickly for you, most of you know this quite well. There, can this be seen? So let's go back to the home page. This is what it looks like. Creatormath.com, or you might have to type in creatormath.weebly.com if you're searching it in Google. Sometimes it can be stubborn and it doesn't want to come up. So we are under the Algebra tab. We're passing by the vocabulary. The vocabulary is first, but pass by to Semester 2. This is the table of contents. It goes on pages 2 through 6 of your composition book. You're going to copy all these line items into page 2 through 6. We're going to pass by exponents. Whoops. Go back. We're going to pass by exponents unit. I think we are. Okay. Maybe not. Come on. There we go. All right. So there it is. Exponents. Sorry about that. Modeling two variable data. We'll go by that. And we're in quadratics right here, but we're way down in lesson 13 here. There we are. Factoring trinomials. So don't take this pages from this video. Look back at the original table of contents. By the time you look at this, this could be different. But here's the notes. These notes go on these pages of your comp book. So click the notes. It does take a second or two to load. And sometimes I have to reload it, you guys. Like this is not loaded yet, so I might go back and reload that same one again. And there we go. I saw it refresh, right? Now you can blow it up to the full size. So this is going to talk to you about factoring. It's factoring ax squared plus bx plus c, right? We're factoring, we're saying what two numbers multiply to equal the tail and add to equal the middle term, and we come up with two binomials that are being multiplied. Here's several examples on factoring. Here's a recital, what two numbers which when multiplied equal the tail and add to equal the middle coefficient are the correct factors of the factoring. There's some interesting things in here, like 3 dots is therefore. A quadratic is that produced by 4 multiplication steps, FOIL. A trinomial is, a quadratic is also anything to the power 2. A trinomial has 3 terms. It's a 3-term expression. A binomial is a 2-term expression. Some other things in your notes that will help you understand these problems, right? Explanation of a coefficient, a constant, and some problems to work with. So as we work through the problems, those notes will help you, but that just explains what that is. Since this is the 13th lesson, we can go kind of quickly because we've done factoring before. We're looking at this trinomial, and we're trying to ask, you know, what, when we reverse FOIL, how does this thing play out into two binomials being multiplied by each other? So what two numbers multiply to be negative 27? How about a 3 and a 9, right? So a 9 if it's positive, and a 3 if it's negative. 3 times 9, negative 3 times 9 is negative 27. That's good. And when you add these, 9 minus 3 is 6. Now, I started to look at this middle term as I started to think about those factors. Sometimes teachers will have you list all the factors, and you can do that at the beginning. But at some point, we need to go faster and just say, let me think about these in my mind. All right, 3 times 9 is 27. One of them has to be negative to produce a negative. If I add, let's say it was negative 9 times positive 3, that would be a negative 6x when added. So I didn't like that one, so I put the negative on the 3, and I did that on the fly, and I know that this is going to add up. So we're going to put an x here, an x here. We're going to say a plus 9 on one and a minus 3 on the other. And you're always going to keep FOIL in your back pocket and just multiply it out to see if you're right. You're going to say first, outside, inside, and last. First is x times x is x squared. Outside is negative 3x right here and here. Inside is plus 9x. And last is negative 27. And that's why we say when added together equal the middle term, because these are like terms. 9x minus 3x is a 6x, minus 27, x squared, and plus. There we go, because 9x minus 3x is plus 6x. So I'm probably going quicker than that. That's sort of a review from factoring, which we've been doing quite a bit through this unit already. Let's go here. What two numbers multiplied equal 48 and then add to be a negative 14x? Well, 6 times 8 is 48, right? 6 times 8 is 48, so that's good. And 6 plus 8 is 14, but notice there's a negative here. What if these were both negative? Is negative 6 times negative 8 positive? Yeah, positive 48, and it adds to be a negative 14. So I know that this is two binomials, and it's really a lot easier for me when there's no lead coefficient. When we start to have a lead coefficient, it can get a bit more challenging. We got a minus 6 and a minus 8. Check. And I'm not going to FOIL all of them. I'm going to leave that up to you. But that's your way of checking whether the answer you got is correct. All right, what two numbers equal 45? 9 times 5. How about that? And they do add to 14. But to get a negative, I need a negative 9 times a negative 5. And I'm going to get x minus 9 times x minus 5. And just to think through it a little, minus times negative is a positive, 45, good. And a negative 9x and a negative 5x is a negative 14x. Go to the next. How about 6 times 7? And that is 13. And they're both positive. So x plus 6, x plus 7. Even the signs are easy for me because I don't have to do any negatives. Everything is negative. It's positive here for both, and it's positive here for adding. All right, 15. 3 times 5, right? And they're both positive. X plus 3 times x plus 5. Just do FOIL, reverse it, first outside, inside, last, to see if it works, right? The only reason I'm going more quickly is because we're so far into this unit now. We've done quite a few of these factoring. All right. Well, they're going to step it up a little. They're going to give us a lead coefficient. I rarely like a negative in the lead coefficient, so I'm always trying to pull a negative out of this statement. I'm looking to see if I can pull a 9 out. Does 60 divided by 9 work? No. 36 does, but that's not good enough. I need it all. So how about 3? So I do see some of the answers. I'm going to cheat a little. I'm going to get rid of the 9s because they don't divide through evenly. And I'm going to say let's divide through or factor out a negative 3. So negative 3 factored out gives us a 3x squared. Negative 60x divided by negative 3 is a positive. 3 times 20x. There we go. And this becomes positive and 12 here. Now I'm trying to look at what my different options are. Right, so I still have the negative 3 out front. I know I'm going to break this into two binomials. I do need the tail to multiply into 12. So I'm probably 3 times 4, 2 times 6, 1 times 12. Those are my options, right? I need this to come out to be a 3x squared. So let's go ahead and say 3x here and x here. That way 3x times x will be 3x squared. So I'm okay with the lead terms. Now I'm trying to balance these signs. This is positive inside, so I'm probably dealing with two positives. I probably have a positive here. Well, let's see. If it was 3 and 4, because 3 times 4 is 12, right? Let's put a 3 and a 4 here, 12. That would be 3x and a 12x. That would only be 16x. That's not 20. I need something bigger. So let's go 6. 6 times 3 is 18, and 2 times x is 2. And now this is going to work. So I'm literally doing FOIL on the fly here. I'm multiplying in my mind. 3x times x is 3x squared. I'm doing the outside, which is 18x, 2x on the inside, which adds to 20, and 2 times 6 is 12. So there we go, right? And they put 3x plus 2 in the second term. That's okay. Remember, you can reverse any of these. It'll still multiply out the same. All right. What can I divide out of this? I don't have a negative in the lead term. That's okay. 16. How about a 4? Does 4 divide evenly through here? No, 15 doesn't divide evenly by 4. I can't divide these by 16. How about 2? 2 doesn't work. I can't really pull anything out, so I don't like these answers there. And I might just go the route right now. Let's go backwards. Let's just FOIL this. Let's do these two. 4n squared. This would be 4n times 4n is 16n squared. All right. Outside is plus 12n. Inside is minus 20n. And negative 5 times positive 3 is negative 15. When I combine like terms in the middle, I get 20 minus 12, but this is negative, so a negative 8n minus 15. So I would use all my options to solve these. And I would go, on this route, I would go backwards. Let's see what else we got. Okay, a 20. Can we divide anything out of 20, 21, and 5? Does anything divide out evenly? Well, a 4 doesn't, because a 4 does not divide out of a negative 21 or a negative 5. So these are out again. Right? And notice they gave us these answers are reversing the sign. So I'm almost certain I have one of these options. It's just depending on how the sign plays out. I need the tail to be a negative 5. Both of these are. I need the inner part to be, the inner term, middle term, to be a negative 21. So this one would be 25n minus 4n would be 21n, but it would be positive. So this one's out. This would be negative 25n plus negative 4, which would be negative 21n. I'm doing a combination of strategies to solve these, and I'm going to leave this to you to figure out, given all the other practice we've had and the other videos we produce on this too, where we take a lot more time to do each one. Let's see what we've got here. Can I pull 2 out of each term? No. So I'm going to get rid of this and this. That means I've got a 2x somewhere, right? An x. 2x times x is x squared. It looks like I have all positives. How about a 1 and a 3? So 3 times 2x is 6x, and 1 times x is 1x, plus together would be 7x. Added together would be 7x. 1 times 3 is 3. So the 2x plus 1, remember we can reverse the order to what doesn't matter in multiplication. Can I pull a 6 out? 6 comes out of this term evenly, out of this term evenly, and out of this term. So let's pull the 6 out and rewrite it. It's going to give us v squared plus v minus 90. And anytime I end up with 1 here in the middle, I'm thinking 90 times 10. 9 times 10 is 90, right? So, and this one's positive. So what if I have a positive 10 here, a negative 9 here? Let's see if I can write this out clearly enough for you to understand what I'm doing. A v here and a v here. So this would be negative 9. This would be 10v minus 9v would be 1v, and this would still multiply to equal here. So did I match it up? 6, v minus 9, check, and v plus 10. And you're really doing FOIL enough times that you're able to repeat the FOIL process in your mind. That's the way you're doing this. How many more we got? Oh. All right, I recognize these from the special lesson. The special lesson says that when we multiply two things together squared, see how these answers have two of the same binomials, like x plus 11 times x plus 11? That's what x plus 11 squared equals, right? So two of these. And now I see the 121 here, that makes sense, and I see that 11x and 11x is 22x. This makes sense to me. I can come straight here, and I can tell you right off the top of my head from the prior one we did, this one's got to be x minus 11 squared. Why? Look at the pattern. Here we had positive, and it was positive. Here, once we go negative on this middle term's got to end up negative, but because negative times negative is positive, it's got to be here. So this depends on you doing enough problems where you can start to recognize the patterns. All right, this one is one of the special, multiplying special products, I think is the name of the lesson. And what's happening is there's no middle term. Anytime there's no middle term, I'm looking for x plus 11, x minus 11. Why? Because when we multiply these, we get x squared, outside is negative 11x, inside is positive 11x, outside is a negative 121. So anytime I see the negative on the tail, and I see no middle term, gone, right? And we love these kind of problems as math teachers. They're so cool to us because it almost ends up hidden. So this, oh, there you go, done. This looks like 6 times 6 is 36 and 6. So I'm thinking x plus 6 times x plus 6. And that turns into x plus 6 squared. And just FOIL it backwards to go backwards. This has a negative in the middle, so I'm thinking x minus 6 squared. And the reason they gave us patterns like this repeatedly is for you to see if this is what an x plus 6 squared looks like. See the plus 12? And this is what an x minus 6 looks like. See the minus 12 in the middle? The negative 12x? That's the very interesting part where you kind of compare the different problems and you can go through them more quickly. Make sure you're practicing these. You're going to go a lot slower than me at first, but you're going to struggle through each one. Then look at the answer sequence and then go back and try them again. Make sure you're matching up the right unit, quadratics. Make sure you're matching up the right lesson, number 13, factoring trinomials. Trinomials because there's 3 terms in the expression, and it's on creatormath.com under the Algebra 1 tab. I hope that helps.